Hi guys! So I spent the past little while building an open source FPGA pedalboard that I call the KFX Engine. If you have a DE1-SoC, you can download the bitstream file and start jamming today. This is actually the second video of me doing this project, and while you don't need to watch the first video to follow along, if you're curious about what I did originally, check out the video linked in the description. Now I'm going to give a high-level overview of the features and how to use this project. If you just want to see me play with the pedalboard, skip to the timestamp on screen right now. Now, let's dive in. The heart of this project is a 12-stage real-time DSP pipeline made in System Verilog for the DE1-SoC, which is here. It uses the on-chip Wolfson WM7831 audio codec to interface with the board's line in and line out ports, successfully processing 16-bit audio at 48 kHz with under 1 millisecond of latency. Now I'm going to briefly go over the effects chain. I'm not going to go into how it's implemented, but if you're curious, you can check out the code in the description. First, it goes through input staging with a gain, gate, EQ, and then compression. After that, it goes through tone shaping with distortion, another EQ, and then a stereo chorus. Then, it goes through time-based effects by first going through a gain controlled by the expression pedal, a tap delay, and then a reverb. And then finally, it goes through two more gain controls to control the output volume. The first one controls the volume of the selected bank. The second one is the master output volume. To tweak your sound, you first select the target bank, and then you use the onboard switches to map to the specific effects and parameters. You can check the GitHub repo for the exact mapping. And then, you want to use these two push buttons here to increment and decrement the parameters accordingly. I've also implemented a non-volatile save state by flipping this save switch here, which writes your parameters to flash memory, so your presets can persist after a power cycle, like so. To make this practical for live use, I've implemented a bank switching system, which allows you to store 4 distinct sets of effects parameters and toggle between them instantly. Right now, I have bank 0 set as a clean tone, bank 1 set as a distorted lead tone, bank 2 set as a light drive tone, and bank 3 set as ambient swells. Now, as you can see, this is not just a DE1-SoC, but also has a lot of peripherals, and I'm going to explain them. So firstly, you have this box here. This has the breadboard, as well as a 1/4-inch input jack that I put in that connects to an aux cable that then gets connected to the line in port of the DE1-SoC. Then, I have these bank select buttons, which allows you to switch banks on the fly. And then, I have this expression pedal, which controls the expression gain that I described earlier. Now, there is also a tap mute button, where if you tap this periodically, it will set the delay tempo of the tap delay, as you can see by the periodic flashing of this LED. And then, when you hold it down, it will mute the board and turn on a tuner mode, which is implemented with the yin algorithm. If I play notes, you can see it can detect notes and tell me how to tune it. Now, enough talking about the board. Let's finally play it. Thank you for staying till the end. This entire project is open source, so if you want to take a look at the code, contribute, or download this to your own FPGA, take a look at the repo link below. Now, I know I haven't been posting recently, but that's just because I'm working on something big, so look forward to that. And if you don't want to miss that, be sure to like, subscribe, and share this video. Do all that other YouTube stuff. And that's it. So, yeah, I'll see you guys sometime.